2, 1.
This is e-learning assignment number 1, the bicep testing week. It's a review of chi-squared because you're going to be doing this with your project. I'm going to go through this kind of quickly. There's a bunch of other videos on chi-squared on Canvas if you need more help. I'm going to hit some different points here. Number one thing is when you look at your table, we look at the two different characteristics, hair color and eye color, and we're always checking to see if they are independent. Chi-squared is a test for independence. So eye color is independent of hair color. Okay, so that right away we're checking for that. A couple of things I like to notice, there's not totals here. So we would need totals if we're finding expected values. And that means if I'm using my calculator, this is what I enter into my calculator. The other thing is they say tested at a 5% significance level. And they're telling you the critical value. I put the table on here so we can do a little matchup. But you don't need the table if they tell you the critical value. Okay, so I'm kind of skipping around. I'm not going to do H1. I'll let you do that. It says find the degrees of freedom. Rows -1, columns -1. There's 1, 2, 3 rows. And there's 1, 2, 3, 4 columns. So 2 times 3 is 6. So that's where this 12.59 comes from. It's 6 degrees of freedom. The rejection inequality, chi-squared, calculated, what we get down here, should be greater than 12.59. That's our rejection inequality. If it's true, we reject. Since we're testing at 5% level with the opposite, if P is less than 0.05, we get the same result. Okay, so second part here is find the expected values by hand and then verify on your calculator. I'll just show you one or two to give you a little reminder here. So for the expected value, we need to have row and column totals. So for instance, if I want to find, I need to find the total here. There's 42, 44 black and blue, 24, 45, 50, I believe I counted that right. So if I want to find the expected value, and there's 150 overall, the problem says. If I want to find the expected value for someone who has blue eyes and black hair, I take the row and column totals multiplied together, divided by the overall total. Okay, so notice it says find these values by hand. This is your e-learning assignment. You can make a table and multiply these out, 3 sig figs. You can double check them on your calculator. Okay, and then we're going to show how to do chi-squared the long way because this is what's coming up for your project. You're going to have to set up a table like this in Excel at some point. For right now, we're just reviewing the process. So what goes here would be all of the expected values from this table, and you can just do them in 3 sig figs. So for instance, the blue and black hair, that number up here was the 10. So we're talking about this value right here. So I'm going to go ahead and show you how I'm going to get that number. 44 times 50 divided by 150 is 14.7. So to find chi-squared, we just keep working our way across this table. And you can do this on regular paper, make your own lines. So you subtract expected or observed minus expected. And then you square that result. And then you take that squared result and divide it by the expected. You always divide by the expected. So 1.5. So you're going to do that for each of these values. Just to get used to that process, we'll use a spreadsheet later. And then this total here, when you add up this last column, that's your total chi-squared. So you can go back and fill in those individually. To do this from the calculator, remember, we go to matrix, and this is a 3x4. Just so you know, I put the numbers in ahead of time. It's like a cooking show. I cooked it ahead of time so we don't have to wait for it. So they are listed in here. Things to be cautioning about is that there's a 2 there. It means we could end up with values in our expected that are less than 5. And there's a 4 here, there's a 5. So when we do our chi-squared test, stat, test, chi-squared, A is where my observed, B is my expected, and I calculate the chi-squared. So I have my chi-squared value, 18.4, and the p-value is 0.00528. So I got those two numbers. You need to check to see. You should be close on what you get by hand. It won't be the same thing. And then you're going to make a conclusion based on your chi-squared value and your p-value. So you're going to go back up to this rejection inequality. So you say we reject or fail to reject based on that information.